All right, guys, we're gonna go ahead and get started. Can you still hear me okay?
Yeah, I can hear you.
All right. Okay, so this is our final lab. This is our final meeting of the semester. I was thinking about what I wanted to choose to do as a final lab. I chose to do a topic that I think is a source of confusion for even many people that know electronics, and that is the topic of ground. So I want to talk about ground. What do we mean when we use the term ground? And the lab today deals with a particular type of ground. So let me start by asking a question to you guys. You probably heard the term ground in reference to electrical circuits or maybe electrical engineering. Does anybody know what that means? When you think of ground, what do you think of? Anybody have an answer for that? Ground.
I think of when I get in trouble when I was a kid.
So you think of when you were a kid? And what did you think of when you were a kid? What does ground mean? What does it mean to you?
That was a bad joke. Getting grounded as a kid.
Oh, grounded. Okay, I didn't hear your comment. You got cut off. You said you didn't get grounded as a kid. Okay, I got spankings. I didn't really get grounded, so I would have preferred to get grounded. But well, back in the old days, you could do that. You could spank your kids and get away with it. Well, let me give you. Go ahead. I want you guys to take notes because you probably won't find this in your book anywhere. Take some notes, and we're going to deal with a particular type of ground. And so I'm implying that there's different types. When we use the term ground, it has different meanings. So I want to list some of the most common types of ground, and then we'll talk about each of them. And the lab deals with one specific type of ground. So let me list out some types of ground. You might think to yourself, well, I didn't know there were different types of ground. Well, it turns out there's earth ground. There's common ground. There's chassis ground. And there's reference ground. So earth ground, common ground, chassis ground, and reference ground. So it's confusing. There's different types of ground. And then on top of that, sometimes they mean the same thing and sometimes they don't. Sometimes chassis ground and common ground can mean the same thing, and then other times they don't. So let's go through and let's talk about these different types of ground. And I'll just say right off, the most important ones for you to understand is this one and the last one. This one was just good to kind of know about, earth ground. And the last one, well, that's what your lab is about, reference ground. So let's go through and talk about what these are. So earth ground is just what the term suggests. It's a physical connection to ground. Now, why would you want to do that? Why would you want to have a physical electrical connection to ground? Anybody know that? Why would you want to connect an electrical circuit to the earth, to earth ground? Why would you want to do that? Anybody know where that's done? I'm looking for a prop. Let me see if I can find something over here. I don't know if you guys can see this in the camera. This is a cord. This is a cord off of probably a computer or something. And I'm looking at this cord. The back of this cord plugs into the device, and the other end plugs into the wall. But if you look at it, there's three prongs on here. This is a three-prong plug. These are male plugs. They go into the slot, and the male the prongs, there's two I call two blade prongs, and there's this other long one in the middle at the bottom. Anybody know what that's for? You ever wonder about that?
That's the ground one, isn't it?
Exactly right. That's ground. Now, what do you mean it's ground? Well, what we mean is when you plug this into the receptacle, into your plug, there's a physical wire that connects to the earth. If you could shrink down and go inside, let me draw the plug. So you know where to go. The two blades go like right here. Sometimes the one's a little longer than the other. So the two blades, that's actually your AC power. That's the power. They go into these two slots right here. But then you got that one that's kind of rounded. Often it's like that. And that's where that ground plug goes in to that slot. And if you plug it into the receptacle, if you can shrink down and go into this hole right here, you'll see that eventually that wire ties to the earth, ties to the dirt. If you go in your basement, sometimes what you'll see, if you look at your circuit breaker box, sometimes you'll actually have a copper wire. It's bare. You'll know it because it doesn't have any insulation on it. It's a bare copper wire clamped or screwed to your panel, your breaker or fuse panel, and it'll go over to a water pipe, and it's clamped on the water pipe. Now, the reason it's clamped on the water pipe is because at least the old water pipes are made out of copper, and that copper water pipe actually goes into the ground. And so some houses are grounded through the water pipe and then to the earth ground. Now, why would you want to do that? Well, it turns out that current wants to go to the ground, especially AC current. It wants to go to the earth. It just does. It wants to go to the ground. Lightning, when it strikes, is trying to go to the ground. Well, it's trying to discharge the ground. Actually, depending on the type of lightning you're talking about, the path of electrons is usually from the ground to the sky, but there's different types of lightning. That's a whole nother subject. But basically, think like this. Current wants to go to the ground. So why do we have it here? And if you live in an older house, I do real estate investing. I have a couple properties that are rent out. And my older properties don't have that ground prong. I mean, it's just a two-blade plug, and I have to go through, because most devices you buy now are three blades. They have that ground prong, and so I have to go through, and either you got to buy a thing called an adapter, which will turn the three-prong plug into a two-prong plug, so I can plug it into here, or you got to replace those receptacles with three-prong, which is usually what I do, just for convenience of the tenant. But as I said, if you can shrink down and go into this little hole here and trace the wire where it goes, you will see it physically ties to earth. Now, why do we do that? Well, the reason we do it is for safety. For safety. And here's what I'm saying. Let's say that you have a machine, like a dryer, washer, a stove, something like that, and you didn't have that third prong. In the old days, you didn't have that third prong. So let's say you had like maybe a 220 volt washer or dryer. Usually the dryers can be 220 volt. And you know they have a metal cabinet or case that they come in. So let's say this is your machine. Maybe it's a dryer. And it's ungrounded. And so on the inside of the machine, you have electrical stuff. You got the motor, you got switches, you probably got relays, you got a whole bunch of stuff, electrical stuff. So I'm just going to draw it. You know, you got motors and you got different things in here that are electrical, but you got wire in there that when you plug this into the wall, if you have just the two wires that plug into the wall, maybe these wires go to the motor, some other high voltage stuff inside of the machine. Well, let's say for some reason there's some kind of fault. Maybe you have a break in the insulation of the wire, or maybe a wire came loose. Some kind of way, one of the wires is kind of touching against the metal case, and you have a high voltage. Basically, what you've done is you've electrified this whole case, but the electricity can't go anywhere. It wants to go to the ground, but it can't get there until you come over and you lean against it. When you lean against it, depending on what you're standing on, let's say you're standing on the wet floor or something like that, depending on what you're standing on, you might have just grounded it. And if you grounded it, this thing is at a high potential, those electrons want to go to ground. They don't have a path, but if you complete the path to ground, guess what happens? Those electrons go through you. Depending on how much current it is, it cannot be good for you. Could be pretty bad for you. So how do you guard against that, since electrical devices are literally everywhere? Everywhere there's electricity now. But what you do is you add to these two power wires, you add a third wire. Now these power wires actually go into the machine to the electronics inside of the machine. So maybe you're powering the motor or whatever else is in there. But that third prong on here doesn't connect to anything electrical. It actually connects to the case or the chassis of the machine itself, and it goes out to ground. Now sometimes you'll see ground drawn like that. Sometimes you'll see it drawn like that. Those are actually two different symbols, but we'll go with this. Most people know that one. So this is tied to earth. So what happens when that's tied to earth? Well, since this case is metal and you have it tied to earth ground through here, the other end of this has a screw or some kind of connector that connects that wire inside of here to the metal case of the machine. And then when you plug this into the wall, through here it's connected to earth ground. So basically, this whole metal case is at ground potential. So let's say I walk in there now, I have the same situation where I have a broken wire, it touches against the case, and it electrifies it, and now I come in and I lean on it. If I lean on it and I'm grounded, current will not go through me because it has no reason to go through me, because I'm at the same potential now as the machine, because it's already tied to ground. By tying it to ground, you put the case at ground potential. Current can only flow when something's at a higher potential. But by connecting that wire to earth ground, you force it to be at ground potential. And if I'm already at ground potential, when I touch it, current has no reason to flow through me. If you were to break that wire, that ground wire, or you take it off, now this thing is no longer at ground potential. So when I touch against it, it's at a higher potential than I am, it's going to flow through me. But as long as I have it connected up, it forces that case to be at ground potential, and current has no reason to flow through me or a child that's touching the case of the machine. So to write down that earth ground is for safety. And we usually deal with earth ground when we deal with not electronics. Of course, deals with electronics. The title is Fundamental of Electronics, or Electronic Fundamentals. Electrical is a different thing. That's what you deal with in your house. So electrical circuits, wiring. So earth ground usually deals with electrical type things. And then there is common ground. And common ground, again, is exactly what the term means. Common ground is a common connection. So what I'm saying is, let me draw a circuit. So suppose I have a circuit like this, where I got some kind of power source, and I have this, I'm just going to draw these shapes. So this is maybe some kind of machine, and this is some kind of machine, and this is some kind of machine, and this is some kind of machine. So I got this voltage, and I got all these machines tied to it. Well, if I wanted to, this wire down here, since that's a common connect, this is my positive potential, and that's my negative potential. And a lot of times, some people call that ground because it's negative, but it doesn't have to be. It can be, but it doesn't have to be. But since there's a common connection to that negative terminal all the way across, I can call that common ground. The way I can do it, there's two ways I can do it. I can erase this, and sometimes you'll see this ground symbol here, 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 and here. And all that means is there's a common connection between these 2 points. I can actually erase that, and this is showing that there's a common connection between those points. Or sometimes you'll see it like this. You'll have a triangle. And again, if I see that, that means that all these points are connected together. Now with this triangle notation, what you can do is you can number them. So maybe there's a common connection between these three. So I might put a 1 here, a 1 here, and a 1 here. And maybe these two are not connected to that, but maybe these two are connected. So I put a 2 here and a 2 here. So when you have common ground, but you have different common grounds, you can use that notation with the triangles and you can put labels on those. I've seen that before. So common ground is just a common connection. Okay, what's chassis ground? Well, chassis ground is often used in like anything with a chassis. The chassis is like a case that houses the electronics or houses something. Now, the most common example that I can think of with chassis ground is your car. Your car uses chassis ground. Let me show you what I'm saying. So now, back in the day, they made cars out of metal. I think there's a lot of plastic and fiberglass in cars nowadays. Let's say you had an old car made out of metal. So here's my car. I'm not a good artist, so I'm just going to draw an old car like this. So there's my car. And in the car, I have a battery. So I'm going to draw my battery right here. And you know that battery has a plus and a minus. Now, I don't know if you know this or not, but does anybody know the purpose of the car battery? What's it for? Just for one purpose. What's the purpose of your car battery?
Start the car.
To start the car. A lot of people don't know that. The only reason you have the car battery is to start the car. Once the car is started, the battery becomes a load and is being charged by the alternator, and everything in that car is being run by the alternator, not the battery. Now, I take that back. If you're sitting, let's say you're sitting with your engine off and listening to the radio, well, at that point, you're still using the battery. So it's to start your car and the power stuff that when you have your engine off, you might want to power, like a dome light or a radio, right? Other than that, it's just to start your car. I'm not telling you to do this, but if you wanted to, you can start your car and carefully disconnect your battery, take it out and set it on the ground. Your car's still going to run. Now, when you turn it off, it won't start, but it'll run. So let's say I want to install a radio in this car. I like to listen to music. I bought an old car, didn't have a radio in it. So what I do is I buy the radio and I install it. And you know, the radio needs power. So there's a red wire that comes out of the radio that I will connect to the positive lead. And there's a black wire that comes out of the radio that connects to the negative lead of my battery. I can turn it on. I got my music. And so back around, I don't know, when cars first were invented, that may have been how they did it. They would have electrical stuff in there, not a whole lot back in the day. I don't know if they had radios and all that, but they had some electrical components in cars. You had to run two wires. There's always a plus and a minus. You know that from the class. Somebody got the idea, though. They said, wait a minute. We got all this electrical stuff in the car, and we got to run two wires for everything electrical, a plus and a minus wire. Since the car body itself, the chassis, is metal, why don't we do this? Why don't we just eliminate one of these wires, take the negative lead, or you can use a positive lead, it doesn't matter. In America, well, now most of the places everywhere, they take the negative lead of the battery, and let's just tie that to the metal body of the car, the chassis of the car. And since that's tied to the chassis of the car, now all I got to do is run one wire, one long wire to the battery, the positive, and then the way this is going to get the negative connection is just to take a short wire and tie it to the body of the car. We're actually using the car itself as a conductor, and we call that chassis ground. Chassis ground. The chassis of the car acts as a common conductor. The next type of ground, and this is what's important for us in electronics, is called reference ground. Reference ground. And that's what your lab is about. So I'm going to talk about reference ground. So let's just talk about the word reference. So I want you to think of a reference as a starting point. A starting point. So like, I don't know how much of this you guys can see on you can see my board. But let's say I want to measure the height here. Let me see if I got hold on, I might have a tape measure in my book bag. Let me see if I got one. All right, so I have a tape measure. I had it in my book bag. And let's say I want to measure the height of the ceiling. I want to measure. There's a couple ways I can do it. Now, what you would probably do, if I gave you this tape measure, I said, hey, measure the height of the ceiling. You probably would take, now my number 1 is right here. This is in inches. You probably would take this. That means this end is 0, right? And you probably could measure up like this. You can't see it in the camera, but it's touching the ceiling down. And then I can run this all the way down to the ground, and I can get the height of the ceiling. So what I've done here is I have my measuring tape at the top. So that point is 0, and then all my measurements were taken below 0. But I don't have to do it that way. If I wanted to, I could put my 0 on the bottom of this, maybe climb on the ladder, and put my 0 on the actual floor and move this up that way. And so now my 0 is, this is 0. Now my 0 is down there, right? Now 0 is usually my reference. When you make when you deal with numbers, usually you don't have to, but usually you use 0 as a reference. When you make a graph, a Cartesian coordinate system, here's your x-axis, there's your y, that 0 is a reference. So once you put 0 there, you can start counting 1, 2, 3, or this way, 1, 2, 3. Your reference is this. Once you know where your 0 is, you can get the other numbers to the left or to the right. So by default, 0 is usually our reference. And if my 0 is up here, we don't do it this way when we're measuring. But strictly speaking, if you go below 0, then these numbers are negative. This would be a -1, a -2, a -3. That's not the way you record measurements, but like over here you do, don't you? If my 0 is here and I'm going this way, these numbers are negative. This way, my 0 is down here, that's like going up that way. So there's really the length and then which way we're measuring, where if I go below my reference point, those numbers are 0. If I go above my reference point, those numbers are positive. If I go above my reference point, my 0, those numbers are negative is what I meant to say. I think you get the idea. But there's no reason if I'm measuring, say, the height of the ceiling, that I have to have my 0 up there, this end up there, or my 0 down there. If I wanted to, I don't know if you can see this in the camera, but I got my marker sitting on this thing right here. If I wanted to, I can make that my reference. If I do that, then I got 2 measurements. I can start, the reference is just the starting point. So I can start my measurement right here, and I can measure up from there. Those are positive numbers. Then I got to go and measure down because some of my wall is below this reference, so those are going to be negative numbers. So in other words, I can have the same situation where my starting point, my 0, is right there. So that's my reference. So then these numbers down here will be negative. And then these numbers here will be positive. So I have 3 scenarios where I measure the height of my wall. One is where my reference is here. I took the tape measure and went all the way up there. Number 1 is up right here. So the edge of this is my 0 is up on the ceiling. That's one way to measure. And then all my measurements are down, so they're all negative numbers. Or I can start down here and say, all right, I'm going to put my measuring, start it down on the floor, my 0's on the floor, and take it up like that. My reference is on the floor, and then I can measure up. Or maybe my reference is counting in the middle of the wall. And I start the 0 here, I'm measuring up, I get some positive numbers, and I measure down, I get some negative numbers. In all 3 cases, I get different numbers, but the height of the wall is still the same. Do you see that? See, if I measure here, my measurements are going to be negative. So let's say the wall was 9 feet. If my zeros here is going to be a negative 9. If it's right here, I'm looking up. It's like starting at the origin and looking up. It's going to be positive 9. And right here, I'm going to have some positive numbers and some negative numbers. But the height of the wall in either case, in all three cases, is still the same. It's all 9 feet. It doesn't change. And so that's what a reference is. A reference is just a starting point. Okay, well, you may kind of get that. But, okay, what does it mean in terms of electronics? In terms of electronics, a reference is the starting point. It's the point from which you measure using your negative lead, your black lead. So let me show you what I'm saying. Say I have a circuit. I'll make it real easy. We're going to have a 9-volt battery. And I got 3 resistors. Okay? Each resistor is going to be the same value. And the reason that's important is, you know, if I have 3 resistors, the same value, each one's going to get the same amount of voltage. If my total voltage is 9, that means each resistor is going to get 3 volts. So I got 3 volts across this resistor. I got 3 volts across this resistor. And I got 3 volts across this resistor. So if I take my meter and set it to volts, if I measure across the whole network, I got 9 volts. If I measure across this resistor, I got 3 volts. Oops, I got my colors mixed up. Measure across this resistor, I got my black lead, my red lead. Measure across this resistor, I got 3 volts. Measure across this resistor, I got 3 volts. Measure across this resistor, I got 3 volts, right? You see how I'm measuring it? My red and then my black. And what happens if I do this, guys? If I got 3 volts, I got my red at the top, my black at the bottom. What happens if I reverse my leads? What would I read then? Anybody know?
-3 volts.
I would read -3. You've probably done that before. I still get 3, but it's -3, showing that my reference, I'm put your black lead on your meter when it's on volts, that's your reference. And that's what we might reference ground. Right? So, but look at this. What if I put this symbol here? Now you know this symbol means ground. But in this case, it means reference ground. And here's what it's telling you to do. When you look at a schematic and you see that, what it means is that's your reference point. Take your black lead and put it right there. Just clamp it on there. Don't move it. See, we measure like this. When you see, just put that lead there and don't move it. With the other lead, you can move that around to measure voltages with respect to ground. So if I put my black lead right here, let me put some points here. This is point A, this is point B, this is point C, and this is point D. So if I have that symbol there, I can measure V at A, V at B, V at C, V at D. And when you see a voltage with just a single letter on it like that, that's called single subscript notation. You can write it down. I won't write it. I have a voltage with a letter after it of the alphabet. It's called single subscript notation. And then single subscript notation, what you got to do is you got to look to see where this symbol is so you know what ground is. Right? So I see ground is here. So the way you read this is, I see ground is here, my reference is there, so I'm going to take my black lead and put it here, and put my red lead and put it here. Anybody know what I would read if I put my black lead here? I never move that. When I see this symbol, that's my reference, so I'm going to clip it right there. How many volts will I read if I'm across the whole circuit? How much will I read? Just guess.
9.
9. What you would say is, the voltage at A, and since it's just a single subscript, the voltage at A with respect to ground is 9 volts. What about the voltage at B with respect to ground? How much would I read?
6.
6. So this is going to be 6 volts. And then the voltage at C with respect to ground, that's going to be 3. And the voltage at D with respect to ground, well, that's on ground, right? So that's going to be 0. You see it? So that's just like me taking my tape measure and put my 0 down this way. So my 0's on the floor. So all these numbers right here are positive. You see what I'm saying? It's like me taking my tape measure and starting my reference point on the floor. So now I'm not spreading this up, I'm looking up. So all these numbers are positive. But I don't have to do it that way. If I wanted to, I can take ground, my reference point, and I can put it right here. I can tie it to the positive lead. I can do that if I want to. Now what that means is take your black lead. Now watch this. I'm going to do the same thing. We're going to measure VA, VB, VC, and VD. If my symbol is there, that means take your black lead and put it right here on the top. And now I'm going to take my red lead and put on the bottom. So I'm going to cross that first resistor. How much will I read? You told me the answer before.
3.
I want to read 3, but since my leads are reversed, what kind of 3?
Negative.
Yeah, this way I read positive 3, but if they're telling me to put my if I'm taking my negative lead and connecting it to my positive terminal, then that's going to be a negative 3. So over here, VA is going to be negative 3. And then down here, actually that's V at A is going to be 0, isn't it? If both my leads are here, my reference is here, V at A is going to be 0 because my leads are touching. So this is not right. This is 0. 0 volts. And then I move down here to point B. That's when I read the negative 3. So this is going to be the negative 3. And then I move to point C. That's negative 6. And then I move to point D. That's going to be a negative 9 volts. You see it? So here, compare that to this. Here, VA was positive with respect to ground, positive 6 for VB with respect to ground, 3 volts positive with respect to ground. Here the numbers are completely different. Some of them are negative, but the total voltage across the circuit never changed. It's still 9. Let's do one more. What if I took the reference and instead of putting it on the top or bottom, what if I put it like right here at point B? Let's do this one more time. Now, I don't know if you'll be, let me put it over here. I don't know if you can still see it if I put it over there. Let's do it one more time. I got a VA, VB, VC, and VD. So this time I'm going to put my black lead here, and VA, when I put it right here, I'm going to cross one resistor, and my red lead is at the top of it, so that's going to be a positive 3 volts. And then when I go to B, my 2 leads are together. My reference is here, I tie it there, don't move it, and now my red lead is there, so this is going to be 0 volts. And then I go with my red lead down here at point C. That's going to be a minus 3 volts. And then I go to point D. That's going to be a minus 6 volts when I take those measurements. Again, I got different numbers, but the total voltage across the circuit is still 9. Just like the height of the wall never changes, maybe my numbers might change, depending on what my reference is, but the total length of the wall never changes. So that's what this is about. You get different readings depending on what your reference is. Now, let's, I don't want to erase one of these. So you got single subscript notation. When you see that like this, that's a voltage at A with respect to ground. And what you got to do is look to see where that symbol is to know where to put your black lead. But then there's something called double subscript notation I want to show you. I don't know if you guys could. All right, I guess I'll try to put it up here. Let me show you. So double subscript notation is like this. It's has shown like this: V, A, B. If you see single subscript notation, what you do is you look at the schematic to see where that symbol is, and that's where you put your black lead, leave it there, and you use your red lead to measure all the points. That'll be the voltage at A with respect to ground, voltage at B with respect to ground, and so forth. But when you see it this way, the second letter is your reference. So B here is your reference, and that means that that's where you put your black lead. So if I want the voltage at A with respect to B, I take my black lead and put at point A, and I take my red lead and put at point B. So the second, if I have two subscripts, the second letter is where you put your black lead. That's your reference. The reference is where you put your black lead. So that's double subscript notation. Now, sometimes you need to go from double subscript notation to single subscript notation or vice versa. So it's a real simple way to do it. Given this is going to equal the voltage at A with respect to ground minus the voltage at B with respect to ground. Let me put a box around that so that stands out. So this takes you from double subscript notation to single subscript notation, or from single subscript notation to double. So here's what it says. The voltage at A with respect to B is equal to the voltage at A with respect to ground minus the voltage at B with respect to ground. Well, let's see how that works. Suppose my ground is here. And so that would be these numbers right here. And it says that the voltage from A to B is equal to the voltage at A with respect to ground minus the voltage at B with respect to ground. So let's see if that's right. Let me get rid of these. And let's look at this. So the voltage at A with respect to B, I can look at this and see what that is. The voltage at A with respect to B, well, that's 3 volts. The voltage at A with respect to B, I'm going to cross that first resistor, that's 3 volts. So 3 volts is equal to the voltage at A with respect to ground. Well, the voltage at A with respect to ground, I'll put my black lead here, my red lead here, that's my total voltage. I'm going to cross all 9 volts. So it's going to be 9 volts minus the voltage at B with respect to ground. So if I put my black lead here, my red lead here, I'm going to cross 2 resistors, that's 6 volts. So the voltage at B with respect to ground is 6 volts. So we're saying that 3 volts equals 9 volts minus 6. That's correct. So you can see that this equation works, but it always works no matter where this point is. Each resistor has 3 volts across it. So I can even use, I can use these numbers over here, right? If I use this one, let's use that one. The voltage at A with respect to B equals the voltage at A with respect to ground minus the voltage at B with respect to ground. We know we got 3 volts across that resistor, but let's see if we can do it with these numbers. Here the voltage at A is equal to 0. So I got 0 volts minus the voltage at B with respect to ground was a -3. Minus -3 volts, that's going to be a positive 3 volts. Well, we know that from here, that resistor has 3 volts across it. So this equation always works. It takes you from double subscript notation to single and vice versa. Now, one more thing I want to show you before we get into the lab. Does anybody know the difference between this? What's the relationship between VAB and VBA? How How do they relate to each other? Just think about how you would get those values. VAB is what? If I measure the voltage at A with respect to B, and the other one is the voltage at B with respect to A. How do they compare to each other?
One would be positive and one would be negative.
Exactly. Because all you're doing is reversing your leads. So I think in your lab, he probably talks about that at some point. Okay? So let's go. Hopefully you got the lab document either printed out. I did send it to your email. Open up your email, look at it on your screen. Let's just look at it. Now, what I want you to do, you don't have to do it tonight, but at some point, read the summary of theory. It'll take you to some of this stuff that I talked about. You'll hear it in a different voice. It'll probably make more sense to you. I'm going to jump right to the lab. On page 43, the materials needed, you need a 330, a 680, and a 1K. I know you got 1Ks. I know you got 330s. I can't remember if I saw 680s in there. So you probably have it, but if for some reason you don't have it, just use another resistor for the 680 and let me know what you use. But I'm pretty sure you got all three of these resistors. All right, so again, make sure, we don't just go get the data tonight, but please go back and read this because there's good stuff in here. I really like the way, it's not a whole lot of reading to do, but it'll make it crystal clear for you. I'm on page 44 now. Look at figure 4.1. What is he doing in figure 4.1? Well, in figure 4.1, he has a 12-volt battery. He has two resistors, R1 and R2. And if you look at it, he's showing you that in figure A, figure 4.1A, notice where he has that ground symbol. Again, it's not grounded there. It's not earth ground. That's reference ground. So all that's saying is take your black lead and put it between those two resistors at point B. If you do that, and notice over to the right of the circuit, he has VA, VB, and VC. Since those are single subscripts, then those voltage are taken with respect to ground. And you got to look at the circuit to see where the ground symbol is. In this case, it's at point B. So the measurements he got is, look, and it makes sense. The voltage at A with respect to ground is what? 4 volts. The voltage at B with respect to ground is 0 volts. And now if he goes to voltage at C with respect to ground, at that point, your black lead is at point B in figure 4.1A, and your red lead is at point C. Then you've crossed them, so you're going to read a negative voltage. So they have a -8. But the total voltage, if you were to use this equation right here across each resistor, would stay the same. Then he says, all right, in figure B, look at what he does. He takes the reference point and moves it from B to C. And he does the same thing again. Notice VA, VB, and VC, they're all different now. In circuit B, VA is 12 volts, and in the other circuit, it was 4 volts. And VB is 8 volts, and the other circuit, VB was 0 volts. And VC is 0 volts when in figure A, it was -8 volts. It's different numbers. But if you use this equation in your resistor, you'll see that you still have the same voltage across each resistor. Your reference point doesn't matter. The voltage difference between the 2 points will always be the same. And that is the purpose of this lab. So any questions on the theory part, what I just went over? Anybody have any questions? Because now we're going to dig into the lab. All right. Look at the bottom of page 44. In this lab, the first thing you're going to do is find those 3 resistors. Now, I'm going to give you guys a chance to sort through your resistors and make sure you have them. And if not, we'll substitute. But I like for everybody to substitute using the same thing if somebody's missing something, if we can. So what you're going to do first is fill out table 4.1. You're going to get your meter, find those 3 resistors. The color-coded values are listed in table 4-1. Measure them to see what your measure values are. Once you do that, you're going to build the circuit in figure 4.2. It's just a series circuit with 3 resistors, but notice the points A, point B, point C, and point D. It's important that you know where those points are in your circuit. And the other thing, you want to have the resistors in the order shown. So make R1 the 330, make R2 the 680, make R3 the 10K, or is that 1K? 1K. So put them in that order. So you'll use figure 4.2 to get the voltage drop across each resistor, and that's what you'll put in table 4-2. You just measure the voltage drops. But instead of giving you V1, V2, they're giving you those points. They're calling VAB is just the voltage across R1, V1. And VBC in table 4.2 is just the voltage across R2. So they're using this symbol because they want you to use the double subscript notation and the single subscript notation. So you'll do that in table 4.2. That should be pretty easy. Build the circuit, measure the voltage drop across each resistor. And then the next part of the lab is when we start the reference ground stuff. So go to the next page, page 45, and now you'll see at table 4.3, what do they want you to do? Let's say make your reference point D. What does that mean to make your reference point D? That means you take your black lead of your voltmeter, you put it at point D, just clamp it on there, and you don't mess with it anymore. You're just working with one lead now, the rail. So with the black lead connected here, you'll find the voltage at A with respect to ground, the voltage at B with respect to ground, C with respect to, so forth. You'll do that. You'll get those values. And then the rest of table 4.3, to the right, they want you to do the voltage difference calculation. That's this. So you'll take the voltage at A minus the voltage at B, and that should give you the voltage drop across the first resistor. And you'll do that for each resistor. Now look at table 4-4, what they want you to do there. Now they've moved the reference from point D to point C. So instead of having your reference here, you're going to have your reference here. And again, all that means is now take your black lead, instead of clamping it right there, clamp it right there and measure VA, VB, VC, and VD. Those numbers should be different in table 4-4 than in table 4-3. They'll be different, but what won't be different is when you do this difference calculation. Over to the right, you're going to do VA minus VB, and those values you get for that voltage difference calculation should be the same as in table 4.3. And then you'll do the same thing in table 4.5, and I don't know if there's another one. Yeah, and then in table 4.6. So you'll move the reference from D to C to B up to A. And you'll see that all your measurements are different for single subscript notation, but when you do this difference calculation, it should prove to you that the voltage drop across each resistor remains the same. And all the lab is showing is when you measure voltages, your reference point doesn't matter because voltage is a difference between 2 points, and that difference will always be the same no matter what your reference point is. Does anybody have any questions for me? Okay, well, here's what we're going to do. Now, guys, don't forget, I hope you're, when you do the labs, you got to write a conclusion and answer all the, that's how you get your grade. I'm going to read your conclusion, and you got to answer those questions correctly. Don't just, think about the answer. That's how you get your grade from me. If you miss questions, you miss points in your quizzes. On your labs. But I want to give you a chance to go ahead and do that first circuit build just to make sure you got it, and then I'll show you briefly how to measure. But I'm not gonna stay while you do the lab. I think now at this point I should be able to back up. Hopefully you can see how to use the board and go through the lab. But I will for that first circuit build. I want you to build it. Go ahead, and I'm gonna pause. Go ahead and find your resistors. Fill out table 4.1. Build the circuit in figure 4.2, and then get your voltage drops across each resistor. And write those values in table 4.2, and then do your circuit build for table 4.3. There's really nothing to build. You just move your reference to point D. So I'm going to pause. I'll let you guys, first thing you do is find those resistors, fill out table 4.1. I'll give you time to do that. Try to build the circuit in table 4.2 without me showing you. If you get stuck, it's okay because I'm going to show you here. I'm going to give you a chance to build it. but I'll show you. And then we'll hook up your first reference point, and at that point, I'm going to end it, and you guys can just keep working on the lab. So go ahead, get those resistors, work on table 4.1, 4.2, and then build the circuit in 4-2. I'll give you time to do that, and I will come back on camera here in a little few minutes. Give you a chance to build those. Okay, guys, I want to show the circuit build. Hopefully you had a chance to go through your resistors. And was anybody missing any of the three resistors? Does everybody have the 330, the 680, and the 1K? Okay, well, I want to do the circuit build for figure 4-2. So assuming you have the correct resistors, let me get my camera back. All right, so let's do the circuit build for figure 4-2. And as I said before, it's just a simple series circuit, so hopefully you were able to do that without much difficulty. So I'm going to switch over to my projector. At that point, you can't talk to me through your microphone. You have to use the messaging system to collaborate if you have a question or you need me to repeat something or if there's just some issue. So I'm going to switch over now, and then I'll switch back over here shortly. So here we go. All right. So again, notice that I have the same connection as before. I'm using this top rail for my positive voltage polarity, which is plugged into that output. And then I have my negative here plugged at that pulse. And I'm going to put that in that bottom rail so that I have positive and negative voltage for this. This is actually two prototype boards, one here and then one down here. So I'm using this top prototype board. Looking at the schematic, I see that my first resistor, R1, is a 330. Now, I don't have the actual, I don't know if you can see these colors or not, so I'm not actually using the 330 because I'm not going to actually do the lab. I'm just going to show you the placement of the resistors. So I got a 330, excuse me, I got a 330, so I'm just going to stick that in there. It goes to power, so notice I'm putting that in my power rail up there, my 330. And I'm going to kind of make this look like the circuit diagram on the handout. So I'm just going to put it over here like that. Now it looks like it's plugged into that top rail, but actually one end is plugged into the top rail. This second rail, which was all the way across, there's nothing plugged in it. So I just have the resistor plugged in that. Just for convenience, just so it looks more like the circuit diagram. And I take my 680, and I'm going to connect now. This rail is coming all the way down, so I can connect the wire or the resistor anywhere I want, and then bring it over to one of the columns like that. I didn't have to go there. I could have went on the other side of the canal too. That'll work too, but I didn't want to bend my leads up like that, so I just stretched it across the canal. Remember, these stop at that canal. They don't run all the way across. They're common from here to here, and then this is another one on this side from there to there. So I have this resistor connected to R1 through the rail, and I brought it over here to the other side of the canal. And then to finish off the circuit, I'm going to take my 1K ohm resistor, connect anywhere. I can go in any one of these columns below that resistor, and over to my negative supply, which is that rail on the bottom. So I got connection to here, and then a connection to this resistor through that bottom rail, and then connection to this resistor through that column, and then connection to the negative supply over here through that rail. And I have my circuit connected up. You want to make sure your voltage is set for 10 volts. Set the voltage before you connect it up, and then check it again after you connect it up to make sure it didn't change on you. And then that's your circuit connection, your circuit diagram. And then all you're going to do is you'll take your leads. Let me grab some leads. And for that very first table, all you're going to do is measure the voltage drop across each resistor. Now you got to remember where these points are. This side of that first resistor is point A. Any up to the from here up to that first resistor, the left side of that first resistor is point A. Point B is here all the way over to that second resistor. Point C is here all the way over to the third resistor. And point D is here all the way over to the negative supply. So I can grab, like for point B, I can grab this resistor or that resistor. Electrically, it's the same. So point A, B, C, D, those where the points are. Now in table 4-2, you're just going to take your voltmeter. You're going to measure across this resistor to get VAB. Then this resistor to get VBC. And then this resistor to get VCD. And you record those in the table. They also want you to get your supply voltage. So that would, of course, be my total voltage. So VS, then VAB, VBC, and so forth. And fill out those values for table 4-2. Once you get that, and table 4-2 is like the key table. You're going to compare all your other tables to table 4-2, and you should see that all those voltage drops, even though you're moving your references around the circuit, all your voltage drops, when you do that difference calculation, should match the calculation in table 4-2 if you do it correctly. All right, so on page 44, we're done with that. We move to the next page, which is page 45. At that point, we're at table 4-3. They say, all right, we're going to make our reference point D. So what does it mean to make the reference point D? Well, what that means is you're going to take your black lead and you're going to clamp it to point D and just leave it there. So I'm going to take my black lead, put right here on my voltmeter, leave it there. That's my reference. I'm going to take my other lead and use that to probe around the circuit and measure. So put the red lead here, that's VA. Put it here, that's VB. Put it here, that's VC. Here, VD, so forth. Make sure I have mine. I said A, B, C, D. I might have had my D point. I don't know where I was pointing when I said that. And that would be table 4-3. And then when you move to table 4-4, you're going to move your reference from here to point C. So point C is either here or there. So right here, I'm doing the same measurements. VA, VB, VC, VA, VB, VC, VD. And then in the next table, you're going to move your reference point here. And you'll do the same measurements. And then in the last circuit, you'll move here and do the same measurements. And in every case, your difference calculation should be the same. Now you want to remember one thing. You want to remember that if you have a negative voltage, let's say V at A is 0 volts, and V at B is negative 5 volts. When you do VA minus VB, that negative sign is not that. So this is negative 5 volts. You got to remember it's VA minus VB. So when you do the math, you put VA as 0, so it's 0. Write that minus sign down, and that minus sign right there is a different one. So I got to put that in parentheses, and that would be 5 volts. The minus times a minus will be a plus 5. So don't, when you do your math, I'm saying some students will make a mistake. They'll leave that negative sign out, and they'll be off by a negative sign. So this lab is pretty straightforward. I hope that you guys learned something about ground. You might have been surprised that there's different types of grounds. I think it's a good lab to finish up on. So let me go back to the video thing so you guys can talk to me. Let me see what I need to do here. Go here. Okay. Now, I went to the lab. So does anyone questions about the lab? Any questions about the lab?
I did want to let you know that I haven't been able to see a link on Blackboard to put up the lab 5, I think it was.
Wait a minute, you guys are, hold on a second. I don't know, something's going on, collaborate. Just give it a second. Okay, now, who was that, Danny? Who's talking now?
That was Davey.
Okay, Davey, ask me your question again. I didn't hear anything you said.
Okay, lab 5, the lab on parallel circuits.
Yeah.
As of yet, I haven't seen a link on Blackboard to post that on Blackboard yet.
Well, hold on. Let me check to see why you don't see that link. Hold on. I think I can do this while you guys are here. So.
Yeah, I see 4 and 6. 4 just came up recently.
Okay, well, hold on a second.
I actually sent you an email on Friday, I think it was, letting you know that we couldn't post lab, or I wasn't able to post lab 4. I don't know if anybody else had the problem or not.
I'm about to find out here. Hold on one second. Let's see. This is right here. You said lab 4?
Lab 5 is what I'm talking about right now. Lab 4 is up now. It wasn't on Friday when it was due.
Okay, well, I need to extend that. Hold on a second. So let me see. Let me check lab 4 first and see when the due date is set. Because if you didn't have the right amount of time, I want to give you more time. So right now on lab 4
is currently up.
Okay, I think it timed out and I reset it for the 7th. So let me reset. I'm going to reset everything for the 8th, just so you guys have time. But you said lab 5, you couldn't see that. So I'm seeing lab 5 here. Let me see what the due date is. I don't know why you can't see it. Hold on a second. Okay, it expired on the 3rd. You said lab 5. It was set to expire on the 3rd. I'm going to reset that. I'll reset that to the 8th. So everything's on the 8th now, but as long as you have it done, it should be okay. Now lab 6 is set to expire. I'm going to set everything for the 8th. I'll just set everything for the 8th, just in case you didn't get it done. I didn't want to do that because I didn't want people trying to do all the labs at once, but I'm assuming you guys have been doing the labs. So I do not, you should be able to see all of them now.
Give me a second. Let me refresh my link here. Yeah, lab 5 shows up now.
Okay, now the lab for today, I got to make a link for it, guys. So I don't have that yet, but I'll do it, and I probably won't do it tonight, but I'll do it here. I should probably go ahead and do it tonight though, so I don't forget to do it. So that's the last one. So does anyone else have any questions? Thank you for letting me know that that didn't show up. Anyone else have any questions about the lab?
Email. Oh, never mind.
Okay, well, okay, any questions about anything, not just the lab thing? I was asking about lab, but you have another question?
Yeah, about the extra credit submit. Are we meant to email that to you, or is it going to pop up in Blackboard?
Which ones? Which extra credit?
The Tesla and the magnetic.
Okay, now let's do that. Let's do that now. So hold on a second. So I just gotta think here because I got 2 systems I'm working with. This system and UC, and they used to be the same, but now they're different. So I'm gonna do. We got the Tesla paper, right? Tesla. Now we're saying it's extra credit, but that doesn't mean you don't do it. Because if I do it as extra credit, if you don't do it, it's gonna pull your grade down. So everybody should be doing this. I'm gonna write counts as 1 quiz grade. I'm gonna call it Tesla, I don't know, report. Still. And I'm gonna count as a quiz grade, so we'll make it. I'll make that due on the 8th. It'll be worth 100 points. And 8th. Okay, so here's your link for Tesla report. And then what was the other extra credit? The magnetism.
Yeah.
Electromagnetism. So we'll call that electromag. And then we'll make that also. I don't want to do that. We'll make that also due on the 8th. Now, hopefully, you already got that done. You're just waiting for me to do the link. You know what I mean? I don't want everybody trying to do everything on the 8th because then you'll be messed up. Okay, so here is your link for the electromagnetism report. So you got 2 things here. And now, let me see. Let me see some of your quizzes. I need to give you. We only had 3 quizzes, and then 2 of the 3 are these extra credits. So I'm gonna have to give you. I need to see where our last quiz was over. So between now, well, it won't be tonight, but tomorrow and the weekend, I need to give you at least 1, possibly 2 more exercises to do on whatever we didn't test over. So I got to go back to the videos and look at that. So just be aware of that. It won't be anything that takes a long time, but it will be something to let me know that you're able to do certain basic calculations. So I'm letting you know that now. Put that in one announcement. I'll put it in another one that we'll do definitely 1 more, possibly 2 more. So you want to make sure, because if you don't do 2 quizzes, since they're 60% of your grade, that will definitely affect your grade. So make sure you look for my text and that you do the assignment that I give you. Again, it won't be anything long, but it will be something that let me know that you can do certain basic calculations. And then there were a couple quizzes, I think, at least one that you texted me. I got to go through, and I don't think I ever recorded that grade. I don't know what it was, but I'll go through my text and I'll add that. So, you know, your grade is what it is right now, but there's some things that have not been recorded. The other thing I need to talk to you guys about, well, first of all, anybody have any questions on anything else before I go to my next point? Let me turn this light out because it's shining in my eyes. I'm going to go back to your screen because I think that's darker. Okay. Well, the other thing is, some kind of way I need to get the equipment back that you guys borrowed from the school. If not, you know, that you don't want to have to pay for that stuff. So I don't know the best way to make that happen. I know when people came and picked it up, they had a weekend and then a couple weekdays where they allowed you guys to pick the stuff up. I don't know what'll be best or how it will be best to collect that stuff, but I definitely need to get that and get it back to the lab center so that you're not charged for the equipment. I think what we'll do, well, I'll put it like this. I'll be up at the school on Sunday, probably doing some grading. And so I'm going to send out an announcement to all my students saying if you want to drop something off Sunday, I'll give you the phone number to my office and you can drop it off on Sunday. If you, for some reason, cannot drop the equipment off on Sunday, by equipment is whatever they gave you, the trainer, the components, whatever you came and picked up. If you can't do it on Sunday during the hours while I'm here, then we'll make some time during next week to collect the stuff. But you don't want to keep it because they will charge your account, and you may not see it till you graduate, but then you won't graduate. You'll graduate with owing money, and then you won't be able to get your diploma. So let me see. My mic is currently not working, but I have a question. Go ahead and text your question. I can read it.
Why are we? Never
All
mind.
right. Why do we have to do the extra credit if it's a well, okay, that's my point exactly. So I don't know if you guys saw that. He said why, or I don't know who it was, but why do we have to do an extra credit? So it's not an extra credit, it's an assignment. I hate to call it extra credit for that very reason, because the minute I call it extra credit, in your mind, the extra credit is something that, well, if I'm not doing bad in the class, or if I'm happy with my grade, I don't need to do the extra points. So it's not an extra credit in that sense. I should call it an assignment. Let's call it an assignment. But the assignment was to really not help your grade like an extra credit. The assignment is to expand your knowledge. So it's a required assignment. And I need to stop using the verbiage extra credit. I mentioned that too when I assigned it. You might have missed that. But I mentioned the fact that I'm calling this an extra credit, but it's not an extra credit like I don't have to do it if I don't need the credit type thing. It's an assignment. And so I think the answer to your question is it's not an extra credit. It's an assignment like any other assignment. But I'm going to give you my purpose is two reasons. Number one, it's an easy way to help your grade out because I don't curve at all. I don't curve your grade. So I give these assignments that A, expand your knowledge, B, is related to what we're talking about at the time, and C, I just think it'll help out your grade. So that's why. It's not an extra credit. I won't use that term anymore. But it's an assignment. So you want to go ahead and do it. Every other class extra credit is not required. Did you hear what I just said? It's not an extra credit. You text me back the same thing. It's not an extra credit in that sense. It's not an extra credit like I don't need the credit, so it's optional type thing. It's an assignment. So if you don't like the term extra credit, just forget we ever said that. Call it an assignment that's worth a quiz grade. We'll do it like that. Okay, so don't compare this to any other class because it's not an extra credit to help out your grade in the sense that if you have an A in the course, I don't need to do this because it's not just about the coursework. It's about basically you being educated. And so I asked you to do research on Tesla. Of course, Tesla has to do what we're talking about. And I asked you to do research on electromagnetism. Well, that was a topic in the course. So if that word extra credit bothers anybody, just assume it's an assignment. Forget we ever use the term extra credit. Just say it's an assignment that's going to count as a quiz. Now, I don't know why anybody would not want to do it. I mean, number one, it can only help you. Number two, it's not that much to do. And number three, why would you? I'm not saying this about you for texting that, but it's not going to hurt you to learn a little bit of stuff. So that was my idea. Wasn't to give you extra credit. It's been part of the class since I think I started doing this class in 2013. That's been an assignment in this class since 2013. So you have to do it. If you don't do it, it's going to count as a zero. And there's no way for me to put it in Blackboard and just count it for some people and not count it for other people. Because I don't have a column like your other classes might have a column that say extra credit. I don't have that. It's either a quiz, a homework, or a lab. That's all you got. So it's got to go in somewhere. So you need to do it. If you don't do it, it's going to count as a zero. It's going to hurt you. You'd be silly not to do it. Watch a video, write a summary on it, and you're done. Look up something that interests you with electromagnetism, read about it, write a summary of it, and you're done. So probably takes longer to text the questions why I do it than it does actually just go do the assignment. So it's nothing big or major. It's just something designed to expand your knowledge. So that's that. We mentioned that before, that it's not really an extra credit. So maybe it's my fault for using those terms, extra credit, but that's just what we used to call it. Anybody else have any questions?
Yeah, I got a question. In the syllabus, and I know you talked about it at the beginning. I don't know if someone else asked tonight, but it says that 2 of the quiz grades would be removed.
Mm-hmm.
Is that still a thing, or because I don't know if you've ever mentioned it anymore other than just saying it in the syllabus.
Yeah, I don't. When I set the course up, the course is set up to do that automatically. So when I set the course up, I set up the categories I just described. I go in, I set. So right now they've already dropped. So whatever your grade is right now,
Oh, okay.
it's being calculated with those quizzes already dropped. So I haven't changed anything. Everything this semester is working in your favor. Number one, we got rid of the exams and made the quizzes worth 60%. Number two, as you just mentioned, you're dropping. It'd be anything I give you, you guys should be kissing the ground. I'm giving you extra credit, whatever, because it's really helping you out. Never before I've been teaching since 1996. Has it been this easy to get a grade? And I have people asking, why do I need to do the extra credit? I mean, just do it, get your A or B, and then go on and be happy. You know what I'm saying? So, yeah, I haven't changed anything. Getting rid of the exams works in your favor. Doing the other assignments that I used to call that works in your favor. I didn't go in and change because we only had a few. I didn't change anything. So what you're looking at in your grades, the only thing that can really screw you up is A, not doing the assignment, like that so-called extra credit, or a lab. That can bring you down. But, I'm looking at, well, most of you guys are looking real good grade-wise, and you'll probably never have it like this again because this remote thing, I think a lot of people, at least that I talk to, are being really lenient grade-wise. My purpose is that hopefully you guys are still learning, and it's not your fault that this virus thing happened. It's not my fault either. So you're trying to do the best that you can. I'm trying to do the best you can, and I've cut all my classes a lot of slack. Trust me, a lot of slack. So, I feel a little irritated when people are asking me about certain. Just do it. Just get it done and go. And be. I'm not going to say be happy, but I'm not. The world is just a different place now with this virus. But people are trying to do the best they can. So, at the end of the day, I'm not one of those guys that want to make things real hard. At the end of the semester, I want you guys to have learned something. If you feel like you learned something, and part of the learning was just digging into some of the stuff yourself and seeing what you come up that you like. That was the purpose of that other assignment where you go on a magnetism and you just kind of look up something that you're interested in and then tell me about it. So quizzes are already dropped. The assignments are what they are. So I think most people in the class, I haven't checked the grades lately, but I think most people are going to be looking pretty good because of the changes that were made. So yeah, they're dropped, and I haven't changed that. So if you do the math, you only had 3 or 4 quizzes that counted. You got the 2 things we call extra credits we're going to count as quizzes, and then the 2 lowest ones going to be dropped. So I mean, you can't beat that grade wise. Anybody else have a question?
You mentioned coming up on Sunday to drop the trainers off. I live in Indiana. It's an hour away. Now, I come to Cincinnati every day during the week to work. Sunday probably wouldn't work for me. Would it be possible to meet up with you? It wouldn't necessarily have to be at the school. I could do it anywhere.
Yeah.
But
yeah, what I said was I'm going to be here on Sunday grading papers. So, yeah, if that works, by all means, bring it on Sunday. But if that doesn't work, then next week we'll figure out a way. I mean, I just want you to get it to me. So it doesn't have to be Sunday. I typically, they just let us back into the school, first of all. I've only been here, since you guys, I've been broadcasting from the school, maybe 2 weeks now. I couldn't get up here all summer. But I always come to the school on Sundays to do my grading because I just get away from my family and it's easier. So this will be the first Sunday that I'm back in the school grading. So I'm going to be here probably 4 or 6 hours grading. So if you can bring it up, this will be a good time to do it on Sunday. If you can't, then I'll come up next week. I prefer, if there's 7 students in the class, I prefer not to come up here 7 times during the week. But if I have to, I'll do it. I mean, whatever I need to do for you guys, I'll do it. I've taken students' exams to their homes. I've done a whole, so I'll whatever I got to do for my students, I'm willing to do it. So if you're here in Cincinnati, especially since you live so far away, we can text me and we can work out a convenient time. I only live at the most 15 minutes away from the school if I'm at my apartment, so it's not a big deal for me to come over here and meet up with you somewhere and get it. Just let me know what works for you.
okay, I work down by UC, or not UC, but UC Hospital.
Okay.
So, I mean, I can drop it off pretty much any day of the week after like 5 o'clock. I get off at 5. So, I mean,
okay. So what we'll do is let's not do it Monday because Monday we'll just be getting started, and but I'll say anytime after Monday we'll just text, and I'll probably just meet you in the parking lot or something. I'll come up here, and I'll meet you. It's not a big deal. So we'll work it out. Yeah, that's not a big deal. If you're here working, then that works out. I'll just meet you when you're off. We won't do it before you go to work. We'll do it after.
Okay, if I don't hear from you or don't see any post or anything about you being in town by say Wednesday, I'll text you and we'll set something up.
Yep. So yeah, that'll work. I'm not going out of town. I'll be here. So yeah, we'll get it. So that's not a problem at all. Glad you work in Cincinnati though, because I have to drive to Indiana to meet you somewhere.
Yeah, you don't want to drive all the way down here.
I go there to get my fireworks. I was there. My nephew does fireworks. It was July 25th. I was over there, over at Shelton's Fire, but that's not too far into Indiana. So
no, Shelton's about 45 minutes away for me.
Oh wow! So you live okay? Yeah. Okay. Well, yeah, we'll work that out. That's not an issue at all. So we'll make sure I'll meet you one day, and we'll get that from you. Anybody else have any questions, comments, issues, concerns? Because this will be the last time, unless you text me and tell me to get on camera. This will be the last time we have open camera like this. Now you can always call me here at the office, or you can text me. Anybody else have anything we need to talk about?
Will you be giving this lab to circuits analysis as well?
Yeah, it's gonna be the same thing. So is that Charles?
Yes, sir.
So you get a double, don't you? You just do it one time and you can count it in both classes.
Don't tell anyone that. That's not fair.
It'll be the same lab, yeah. So I think the only difference, I think we went into some more detail in some of the concepts that we talked about. Capacitors, I think we went into more detail. You can compare the two courses. It's kind of interesting because I don't think I've ever had a student to take both of them. So they're kind of the same, but hopefully you saw some differences in them. But yeah, it'll be the same exact lab. So you're good. You're done for your circuits lab. You're good to go. Okay, is that it? I still got 1, 2, 3, 4 icons, and then a +2. I guess 2 people called in. And I'm hoping the call-in people can send a message. I don't know if they can or they can't. The people that call in, are they able to message me through the system?
I don't think those are call-ins. You have to actually click on those that are on the icon down at the right-hand side, and it'll show you who's all here.
Okay.
Yeah,
There's
that
an
just means
icon.
that there's more than like 4 or 5 people here.
Yeah, the main screen will only show the moderator and then show, I think, 3 students. So generally, it's like the first 3 or the first 3 in the alphabet or the first 3 that logged in.
Okay, so.
Or whoever's talking, depending on how you have it set up.
Okay.
Yeah.
All right. Well, I've asked for my classes to be here, and so far they say yeah. Because I don't like this remote. I want to be in the class with my students, although I understand why. So I don't know. I know they're going to let me do the labs, and we just have to social distance and wear masks. They said yes to face-to-face, but they may change that because they're expecting a second wave of this virus. So we may continue doing this remote stuff. Although when I'm here at the school, I feel the bandwidth is better. I have more board space. So that's all good. It's just me getting papers to you and grade. That's a big difference. So I'm not used to doing it that way yet. I've been teaching a certain way since 1996. So my online skills are probably not as good as they should be, but I'm learning. So guys, just kind of bear with me, and we'll get through it. Your other classes are probably a little bit more internet savvy than I am, so I don't know. But again, I hope you guys learned something. I enjoy you guys. I think you asked really good questions, and you do good work. So I'm pretty happy with everybody in the class. I can't think of anybody that I'm unhappy with. So anybody have any more questions before I sign off? It's getting dark here, and I'm going to get out of here if you don't have questions. Everybody's lab go okay? Okay. Well, I see. Looks like Derek, Charles, Davey, Ronnie, and then I don't know what the +2 is, but if you don't have questions, guys, you have a great night. Again, I enjoyed you guys in the class. Hopefully, you got something out of the class. And if you have any issues or questions or concerns, please text me, and I'll send out my office number. I'll be here pretty much all day on Sunday. So if you want to call me on my office phone, I'll be available on Sunday to talk about anything we need to talk about. Grade-wise, I don't know when the grades are due. Sometime next week, but I'm going to try to get most of everything in them by Sunday night, but we'll see how that goes. But again, I think everybody's in good shape. So, guys, have a great night, and I will talk to you later.
Thanks, Chief. See you.
Thank you.